Very good afternoon, guys. We are back. Hope you have enjoyed your morning and your weekend. Um, and here with me to learn about dynamic programming. Well, let's see what it is, what the beast it is, dynamic programming. Looks like the word programming. Well, actually, if you go and read the history of dynamic programming, it was the Bellman Ford was working on a defense project, and he didn't want to use mathematics name or some other name which um, typically military requires. Probably he was not happy with his boss who forced him to do the scheduling job. So he came up with a different name, programming, or in other words, scheduling. So dynamic programming, what it is. So we have seen so far divide and conquer algorithms, right? That's a wonderful approach to deal with many classes of problems, and very important concept in computer science, divide and conquer. However, if you have noticed, in the divide and conquer strategy, your recursive loop doesn't store the information. Okay, so it does computation again and again. So that's fantastic, wonderful if your recursive solutions do not overlap. You do not have to store. But what if your recursive solutions overlap? So if those solutions overlap, then you will have to do recomputation again and again for the same thing. It's like reinventing the wheel. So why to reinvent the wheel? Why not to store the information which we already have computed? Isn't it a beautiful idea? Dynamic programming is the same thing. It gives you this wonderful way of dealing with such problems where sub-problem solutions overlap. You store in a you store those solutions and make use of those solutions again and again for sub-problems. Dynamic programming, like divide and conquer approach, solves the problem by combining the solutions to the sub-problems, with a little difference that DP, dynamic programming, applies when sub-problem overlaps. That's where you get the extra advantage. If your sub-problems do not overlap, then why to store unnecessary information? You are good with the divide and conquer. Alright. DP algorithms solve each subproblem just once and saves its answer and avoid the recomputation. Typically, DP algorithms are applied for optimization problems, whether it can be maximization problem or minimization problem. For example, you want to go on a world tour and you want to minimize your cost. Alright, now how can you minimize the cost? Well, let's say you plan out 10 different cities and you go and sit with your flight booking agent and optimize the schedule. Okay, if I fly from here to Vienna, how much does it cost? Or if I fly from here to Frankfurt, how much does it cost? And then you want to fly from Frankfurt to, say, Amsterdam, how much does it cost? Or if you fly from via Vienna to Amsterdam, how much does it cost? So let's say you have 10 cities, so you keep on calculating. So on each route, which one gives you the maximum optimal choice? It might be possible that from Toronto to Frankfurt is cheaper, but from Frankfurt to Amsterdam is costlier, right? Now, it might be possible that from Toronto to Vienna is costlier, but Vienna to Frankfurt is cheaper, right? So you can see the difference, right? So now this is just one example where you have 3 cities, but think about you have 10 different cities to travel. How will you minimize your cost of traveling, right? So such kind of problems, you typically apply DP algorithm. Well, there are many other ways to deal with this traveling or cost minimization. It falls down under traveling salesperson problem. But to give you an idea that such optimization problems where you can think of a smart recursive solutions where they overlap and you have to make an optimal choice at each stage in your recursive loop. Here we go, DP algorithms. All right. What are the typical steps for a dynamic programming algorithm you would like to take? Okay. So you would like to characterize the structure of an optimal solution. What does it mean? That you should have some way, right, to minimize or maximize your solution or cost. So some kind of formula or method. Then what you do after defining the structure of your optimal solution, how can you recursively design the solution such that at each recursive loop you have choices and then you can select what is the best choice, right? And then third step is typically you compute the solution and store in a memory. And then fourth step is like divide and conquer, like when you have conquered each sub problems, now you are joining the solution. In the same way, you construct and final optimal solutions from the computed information, right? Very simple. It's not complicated, so don't be afraid. It's just an extension to divide and conquer with the benefit of or taking advantage of the fact that subproblems overlap and you can store that information. That's about it, right? Now, many real-world applications, you would be wondering about what are different real-world applications where I can use dynamic programming or why it is so popular. For example, bioinformatics is a very, very hot area for research, protein folding, or you want to do the comparisons of DNA sequence where you have millions of sequence and you want to do comparison. Gene prediction, RNA secondary structure predictions, pairwise sequence alignment. See, so much use in bioinformatics area for dynamic programming algorithms or approach. Financial markets, it's another big area. Let's say you want to do dynamic trading, right? You want to develop an algorithm where you want to maximize your profit. Basically, you are a trader, you are a stock trader. You go buy in the morning and sell in the evening. What if you find a better way to optimize your buy and sell? You can maximize your profit. Option pricing, dynamic hedging, multi-period portfolio optimization. In telecommunication, you see, you use cell phones, but have you ever wondered what are the algorithms behind those 3G, 4G technologies or whatnot? Viterbi algorithm make use of dynamic programming, communication network expansion. Let's say you are working for this telecom giant and they want to expand their communication network. At some point in time, they will use dynamic scheduling or dynamic network optimization, right? Neuroscience, another very interesting area. Reinforcement learning, how neurons learn. How we can develop an algorithm which can mimic the behavior of neurons and can optimize things along the way. Many uses in robotics as well. Multineuronal spike trains comparisons. See, again, these problems can be translated to optimization problems. And here we go. How do we solve a typical optimization problem? By computers, right? You've got to design dynamic or some other, some kind of algorithm you got to develop, right? Industrial, production optimization, inventory optimization, scheduling problems. See how wonderful these dynamic programming methods are. So much of use in many areas of real life. So learn this technique. It will be very, very useful for you guys. Now let's discuss about elements of dynamic programming. So as we discussed that optimal substructure is one element that you should ensure that your problem has some kind of a optimal solution, minimization, maximization kind of problem, and at each sub problem you can each sub problem consists of making a choice, and which the choice leaves you one or more sub problems. For example, let's say you are here, right, and you made two choices, right? Now out of these two choices, which is optimal? It's easy to see, but then again you see at the stage 2, let's say you are at the beginning, now you are at stage 1, right, now you are at stage 2. So at the stage 1, on each side you have two choices, right, two choices. Now then again on second stage you have two choices. So think about this tree keep on expanding, and how much search space you would have. How much search space you can calculate. It becomes enormously huge as your number of stages rises, right? So think about, for example, like let's say you are at year 1, or say year 0 and year 1, year 2, and you keep on going that I want to invest money for 10 years, right? Year 10, how many total choices you will have? Think about. To about 10 is many choices, right? You can keep on expanding, right? Now, and in the optimal substructure, you have a choice of optimal solution. You determine how to characterize the resulting space of subproblem. Also, it can be shown that solutions to the subproblems used within optimal solution to the problems are themselves optimal. Means that, let's say if this path is, say, leads you to the optimal solution, means that this path at every stage leads you to the optimal, or your cost or whatever function you are using is minimizing or maximizing, right? Now another element of dynamic programming is that you have overlapping subproblems, right? That you calculate, let's say you take the decision at y0 and you take the decision of y1 and they are overlapping. So you don't have to recalculate again and again, you just save the solution. And then you have some way of restructuring the optimal solution. When you find out the optimal solutions of all subproblems. And an important element is memoization. That is very important element of dynamic programming. Memoization means you are storing, or your algorithm has a memory which stores the intermediate results, another way to say that, right? Now in simple terms, let's say consider all ways of partitioning a problem into smaller pieces and then pick the best one. In a mathematical form, you can represent it that way. Let's say you want to solve a function f which is dependent on the variable x, right? Now x can be vector or a single variable, and now you are choosing the best solution for let's say a function g which gives you a solution for up to 1 is to k, and x is a vector of 1 to n. So you solve up to 1 to k, and then you solve k plus 1 to n, and whatever is the best you choose. So you apply the same technique at each stage in a recursive loop, right? So that's a very simple way of putting in mathematical terms what we just said. Now always remember, dynamic programming, let me go back. Dynamic programming is about how smartly you design your recursive function. See the difference here? You have so many ways to develop your recursive loop. Important is how smartly you design your recursive function. So smart recursions, okay. Is the term. Dynamic programming allows you to trade memory. What does it mean? That you need more memory now because you want to save your computation time. You just do not want to compute again and again. So you are trading memory for computational time. Good. Now let's say a textbook rod cutting problem. You might have read textbook, or those who haven't read the textbook, let's say what it is. So in simple terms, what the rod cutting problem is, that you are being given a rod of length n inches, right? Now you are also given the price, at what price the piece of the rod will sell in the market, right? Now you want to cut that rod in pieces such that you maximize your profit by selling those pieces, right? So for example, let's say if you have just 1 inch length, its price will be 1 inch. But if you have 2 inches, 2 inches long rod, then it will sell at a $5, for example. Now if you have 3 inches long rod, it will sell at $8. Similarly, you can see the whole table consists of length versus the price at which it will sell. Your job is to find out, let's say if I give you a n inches long rod, so you need to cut that rod into pieces such that when you sell those pieces, your profit is maximum, right? Let's talk about the if I give you the 4 inches long rod, so how many pieces and in which proportion of the length you will cut so that you maximize it. Remember that here we are talking about each piece has to be an integral number of inches, means you cannot cut 1.5. You have to be 1, 2, 3 integral number of inches, right? So let's say how we can deal with the rod of length 4 inches cut into pieces which maximizes our profit. So initially we have 4 inches long rod, and 4 inches long rod we can sell at $9, right? But let's say if we cut into two pieces, first one is of length 1 and second one is of length 3, right? This is 1, this is 3, right? So we sell it for $1, we sell it for $8. Our total profit would be 8 plus 1, $9. Right? Now we have other ways to cut the rod too. Let's say what if we cut a rod in 2 pieces of length 2 and 2, right? So we cut it length 2, 2. So we got length 2 is $5 and another piece length 2 is $5. We can add it together. So how many dollars we got? $10, right? Now $10 are bigger than 9 when you are cutting in a piece of 1 and 3, and if you are not cutting, you sell at 9, but if you cut in pieces of 2 inches, you are getting $10. So it's so far is a good profit. So far, sorry, let me put it that way. So far 10 is the maximum number, means you are maximizing profit if you cut rod into 2 pieces of length 2 and length 2, right? Now we can do more things. We can say first piece is of length 3, we can sell $8, then second piece of length 1 we can sell $1, we got $9, right? In the same way, we can also say that let's cut it in 3 pieces. First piece length 1, second piece length 2, third piece length 2, right? So now let's say 1, 1, 2. Now if we add together $1 plus $1 plus $5, how much you got? $7, right? So that is also not giving us more profit. Let's say what other ways, total ways we can cut the rod. We can also say that okay, first piece is 1 inch, second piece is 2 inches, third piece is 1 inches. Same way, 1 plus 5 plus 1, 7. Okay. Now you can also say that okay, my first piece is 2 inches, second piece is 1 inches, third piece is 1 inches. You can add it up, 7. Or you say okay, I'm just gonna cut it in 1 pieces, you know. So you just cut it in 4 pieces. So 1, 1, 1, 1. Okay, so don't take it this one. This I think I put it extra. Okay, so far we got that our profit is maximized when we cut the rod into 2 pieces of length 2 each. Right? Easy, because your length, I gave you the rod of 4 inches of length, but think about if it is 100 inches of length, how are you gonna do it? You need some way to solve it. You need to develop an algorithm to solve it, right? Now let's say what we can do. We can write a very simple algorithm for cutting the rod. Let's say the algorithm takes the price and the price of the rod of length n, right? And it will give you the it will give you the number which maximizes your profit. Okay. So now let's say you are calling this this routine in a recursive loop, right? So think about, it's a very similar to divide and conquer approach, where you solve the subproblems and then you combine the solutions of the subproblem. Here the cut rod is doing the same thing. However, let's take a look at the graph or the tree, how it will expand. So initially you had the 4 and then you apply the same algorithm on say p and minus 1, 3, 3, and then you keep on solving. Can you see a pattern here, a repeating pattern? Okay, so we see the repeating pattern here. This way it is repeating. So if we solve, So if we solve these subproblems without storing the solutions of subproblems, we're gonna do repeated job again and again. Is there a better way? And remember, this algorithm, very simple algorithm, we're gonna take 2 to the power n. Can we do a better job? Let's see how we can do a better job. So what about we take a new array where we store the result of the intermediate subproblems, and then we call the another routine within this DP cut rod routine. Can we do a better job? So let's say memorize cut rod P and R. So it takes the price and your array or R, which you have taken, to store the values of the intermediate subproblem solutions. Okay. So now you see here, at each step in for loop, you are getting the value or the profit maximized of a subproblem, and you are storing in an array R or in some other memory location. So let's say if we plot the graph or subtree expansion of this algorithm, how it's going to look like. So instead of going through all those sorts of things, you are just shorten it up, because you are storing the solution here and your algorithm returns the value. Say if you are at node 3, so typically it goes the backward position. So first it will calculate 1. So now if you are at 1, you don't have to redo the calculation again. You just know the answer. Okay, I have solved this problem before and I'm storing its, and I'm making use of its stored solution from the R. And this turns out to be that this algorithm takes n square time on an average. So this was a very simple problem where you have divided the problem into subproblems and you have stored the solutions of the subproblems in an array, and then when you call your memorize cut rod routine, it takes the value from this array. It doesn't have to recompute again and again. Now, an interesting question, you guys might be wondering, how can you make more money? Isn't it interesting? Say if you know the technique to make huge amount of money, wouldn't you be happy? You wouldn't have to learn anything. You just go on a vacation, enjoy your time. But in reality, is it possible? Let's go a bit further. So if you guys are interested to make more money, or you guys are not interested to make more money, you have to take a decision now. I'm gonna show you something. So if you decide you don't want to make more money, then you can stop watching this video. Alright? And if you want to make more money, then keep watching and be happy. Right? So let's talk about multi-period portfolio optimization. The guys who are into investments or who are into finance, or who are into any kind of investments, stock investments, bond investments, options trading, stock trading and all, they're gonna love this. However, there is a little hitch. I'll come to it later. So we are talking here about the multi-period portfolio optimization. So let's say two friends, very good friend, Hermione and Harry, right? So very beautiful friend of Harry, Hermione, she comes to Harry and asks with Harry, "Hey Harry, help me to make more money." And Harry, very smart, intelligent guy, he says, "Sure Hermione, you are a very good friend of mine. I will certainly help you. How can I help you?" So Hermione says, "Remember, LeProfessor often says in the class, money never grows in pockets but markets. So I want to invest my wealth in markets. Help me to optimize my portfolio." Isn't it an interesting question? Say your friend comes to you and says, I have this much money my parents gave me, and I don't want to spend it on on drinking or going to here and there. Those are stupid things. I don't want to invest. I don't want to waste my money on crazy things. I want to invest my money. Can you help me to optimize my portfolio? So as you, Harry, a very good friend of Hermione, he says to Hermione, "Oh yeah, LeProfessor words are gems, that's a great idea that you have decided to invest. I will certainly help you. Can you elaborate more? As I'm a bit confused. I don't know how you're gonna invest or what's your plan is. So could you invest a bit more? Could you explain me a bit more?" And Hermione says, "Here you go. Let's say I have initial wealth of say W0, means I have present wealth, right? And I want to invest across T periods, means T may be say 5 years, 10 years with no consumptions, right? Generating intermediate wealth W1, W2 and WT. So this is my parents' money, I just wanna like a piggy bank. I don't wanna keep in that. Instead, I want to grow my money so that when I graduate, I can start my own business. I don't have to go to angel investors or venture capitalists uh, who often are not very supportive or too judgmental. I don't want to do that. So let's say I'm gonna graduate in 5 years. We are in first year, both of us. So by the time I want to accumulate good wealth, so that I start my own business. Okay. And also I want to minimize the risk, right? And let's say there are n risky assets, means I have say stocks, bonds, properties or whatnot. My parents gave me some money, but I want to diversify as well, right? And with the different prices, so different price vector and one riskless asset, because I'm a bit conservative too, Harry. I don't want to put all my money into risky assets. So I want to feel a bit safer. Harry, girls thing, they always like to have a safer thing. So let's say I have a riskless asset too, which is S0. You may think about a bond, for example, government bond. US government is not gonna go bankrupt, very soon by the time I graduate, So that's a very safer investment. I'm gonna put some money into the bonds. But, but the riskless asset has a fixed return that I know, and the excess return on the risky assets at time t I know too. Okay. Now all the excess return vectors are independently identically distributed random variables. Okay, with the mean and variance and the mean and variance. Okay. So Harry, my problem is very simple. It's a mean variance portfolio optimization problem. Help me with that. I was, scratching my head but couldn't get it. How do I do? You are a good friend of mine. Help me. Harry says, That's wonderful, lovely idea, Hermione. I know exactly what you need, and I know what kind of algorithm would be uh, perfect for this kind of situation. Let me develop a DP algorithm, and we'll see you tomorrow after the class. All right, Hermione? Okay. So let's see. Harry promised to Hermione to solve this problem. How are you going to do that? Can you help Harry? So let's say, what information does Harry know at the beginning of each period? So Harry knows that the information set that the returns, okay, and the wealth, how much wealth at each period he has. Right? Now what Harry needs to know, the proportion of the wealth at particular time frame is invested into different assets or stocks, for example, right? And Harry also knows that the amount invested in riskless asset would be the balance amount what is not being invested in risky assets or in stocks, for example, right? So the whole system dynamics can be summarized by a stochastic discrete time stochastic system. The two equations, the wealth for the next time frame will be the function of the wealth at current time frame, and the investments what you are doing, the proportion of the investments and your return, and then this function can be represented by this equation RD RWT E tick YT, and tick is just the transpose of the matrix. Okay. Now another important thing here to note, Harry noted that the series of investment decisions, that how much proportion Hermione has to put in different risky assets, those constitutes a non-participating portfolio policy, or let's define our portfolio policy. Okay, we want to invest not this much proportion, and we came out to be a set, let's say 10 different criteria or 10 different things. We can go to 10 different routes at each time frame for our portfolio. Okay, so we call it portfolio policy, and let A0 be a set of all such policies. And remember, here we have only one constraint on our portfolio, that mean and variance, right? So we want to minimize the variance, and we want to maximize the expected value of the portfolio. So we can summarize the problem in any of the following forms. Okay, we can either say that we minimize the variance for pi in I, means pi belongs to a set A0. Okay, minimize the variance such that expected value of the wealth at the terminal time is some value, or we maximize the expected value for each pi in A0. Okay, so we maximize the expected value of the wealth for a given level of variance. That, okay, Hermione may say, okay, I don't want to have more variance up to this limit, so we can formulate that way. Then we can also say the combined mean and variance, expected value and variance. So combined problem. Okay, if Hermione doesn't like method 1, then I will say method 2, then I will say method 3. Method 3 would be for each value, for each pi in A0, maximize the expected wealth minus for a given risk aversion coefficient. So I can ask what is her risk appetite and minimize the variance accordingly. Now, which one would be more useful? So I would suggest, Hermione, let's go with this sort of equation, and then we solve it together. But you can start for simplicity with the equation 1 or equation 2, depends. So good, you have formulated the problem. Okay, now you haven't developed the algorithm yet, and that's a big question. Harry is thinking, can you help Harry? Can you help Harry so that Harry goes to his beautiful friend Hermione and help her out? Think about it. So guys, I hope you would help Harry in formulating this problem or in giving the answer of this problem to Hermione. Thank you guys for watching this video, and if you are struggling with this subject or any sort of subjects which I prepare videos, you may contact me for private lessons. And do not forget to subscribe LeProfesseur YouTube channel on YouTube. Subscribing, this helps you, and you get notified with the latest videos as soon as I post them. And this helps us too. It encourages us, it motivates us that you guys are liking my videos, and it motivates me to create more interesting fun videos for learning. So please subscribe, and have a wonderful day. I'll see you again for another interesting topic and an interesting video. Till then, have a restful evening. Bye for now.